Okay. Hello, or good morning. If you're here, good morning. If you're watching later, hello. Hope you're having a good week. We've only got 2 more weeks of content here. So hopefully that's feeling pretty good to everybody. Uh, Remember, the goal with the shell scripting is to not make any of us experts at shell scripts. It's really to just to expose you to what's possible in Bash shell scripts. If you've taken programming, then most of the functionality that you're accustomed to uh, in a programming language is available in Bash. Good morning, Justin. Hope you're doing well. So most of the functionality that you're used to from basic programming is available in the Bash shell script. Sometimes it's not as pleasant an experience, so you kind of learn uh, some of the basic tools of shell scripting in Bash, and then you get accustomed to looking up and experimenting before you actually put something into production, which is I think you're all already in this habit if you are sysadmin types, but obviously you want to run tests on things like a shell script before you actually roll them into um, production. And be very, very careful, obviously, about deleting things in a script or altering files from a script until you sort of fully tested away from your production servers. Don't put them into production. Probably you've all also, if you haven't, then that's good for you. But I have made the mistake of putting a not fully tested script into production and then having to unravel the mess that I made. So hopefully you'll avoid that rookie mistake. Okay, so we're in week 15. We have this week's adding a few more tools to our scripting toolkit. Next week, a couple more, the final sort of new content, and then the last week of classes is the final exam. I hope that this week is not overdoing it for you getting the team project in. But I decided not to have that due on the final Sunday, on Sunday, December 13th, because I figured at that point you would rather be spending your time preparing for the final exam. So that's why the team project is due at the end of this week. It's the same as before, so hopefully you are allowing yourself an afternoon or an evening or a morning somewhere between now and Sunday night to do that work. As always, if you find yourself alone or you find yourself in need of an extra teammate because people disappeared on you, please just let me know and I'll step in and fill the gap. But it's the same as the first project. So pick a distribution, install it into a virtual machine, fiddle around with it a little bit, and then fill out that template, that document that I provided with your impressions and the result of some basic research about what the distribution is, what it's meant to be, how people use it, that kind of stuff. Okay, so week 15. Oh, it's Justin, by the way. Props to Justin. Thank you very much, Justin, for finding 2 bugs in this week's lab assignment and helping me get a fix. Yeah, so those are fixed. If you had already worked through the assignment, you didn't lose any points, but if you had encountered the bug and lost points because of the bug in the week 15 lab assignment, then you should have those points back now. So anyway, thank you for the help. It was just at a point I think it's just easy to make mistakes when you're scripting, and that's what a lot of these are scripts. So thank you for that. Okay, so goals for this week. Using Echo, which we've used a whole bunch of times, but we'll add one option just so you can see that there's a different way to use Echo. Yeah, appreciate it, Justin. It helps a lot. I hate having bugs out there, so I was glad for the opportunity to fix it, and also so that you didn't get robbed of points that you earned. Okay, so we'll use echo and add an option. Read and explore a couple of options with read. And probably we've seen these before. The big stars this week are loops. So how do we do repetitive things in a shell script? And finally, select statements, which is a really cool way to automate the creation of menus by the shell. It's really, really neat. This select statement is one of the coolest things I think that Bash does. So we'll explore all of those. And then my hope is that I'll get to the display managers thing, but if I run out of time, I think those instructions should be relatively thorough. I used them with success myself, so hopefully if I don't get time to do a walkthrough of installing desktop environments, you can use this set of instructions to do so for yourself. But I will at least load up the fruits of my work and sort of show you what to expect. Okay, lab assignment as always with the corrections made. So if you already completed it before I made the corrections, then your score should have been updated. Or if you gave the quiz the incorrect answers, you won't have been deducted points for that. So either way, you should come out on top after I fix the lab assignment for the week. Okay, so one more bit of research, which is, and I don't know if you're interested or not, but I thought somebody in the class might be interested in seeing how do we actually install and bring up an additional service on a Linux machine. So far all we're doing is really just exploring the basic operations at the command line, but we haven't looked at anything like how do you run a web server on Linux, or how do you run a database server on Linux, or how do you install additional shells and use those instead of Bash? How do you install the support for a programming language? So anyway, there's a poll this week that's asking you if you have an opinion to weigh in on what you might like to see me do a quick walkthrough on, so you can see how a service is installed and brought up to run in a Linux system. This might be particularly useful, for example, to people who want to either do development on Linux as a programmer or support programmers doing development on Linux. Then having a web server type stack, the installation of web server related software could be useful. So that's what's that about. That is what that is about. Okay, and then reminders as always. So lab as always, discussion as always, and the project, which I hope isn't burdensome. I really, really want you to have not only the working together experience, but the bonus on top of that is that you have, you exit this class having put your hands on multiple Linux distributions. Or if you want to, you could do one of the Unixes as well. But so you walk away from this class and you're confident not only that you can operate in any Unix type environment, but also that if you had to, you could go install a virtual machine, get it up and running, explore its capabilities, and someday, presumably, maybe put it into production somewhere. Okay, so that's that part. So let me switch views and let's go work on the command line some. Make sure that you can see. And let me bring up Notepad. I may need to, yeah, I need to adjust that by a lot. Okay, so there's this week's menu. So echo and then echo with the -n option, so we can see how those two are different, which we've done before, but that'll just remind you. Using the read capability in 3 ways, and then we'll explore loops a little bit, and then finally select statements. These aren't all the loops, these are just the for loop and the while loop are the ones that I highlighted. Okay, so go into my let's see if I've got me a week 15. I do. So as always, I've put, I'll go double check. Let me switch views again. Let's just go double check to make sure that I'm correct when I say this. Why are you down there? Let's go look at the hands-on experiments real quick. If it'll let me move. See what I screen captured in there. Yeah, so I put a whole bunch of scripts this time. These are all slightly smaller, but these kind of touch on the various things that we're doing this week. So the first one has a for loop in it with an if statement checking to see if a file is executable. This second one is actually using a loop to process command line arguments, which we'll toy around with a little bit. My favorite trick, the select statement. So when you try that, hopefully you sort of get the same satisfaction that I do out of it. And then I'll also just call your attention to, I've added in a couple of additional things so that you have been exposed to them. So these are kind of administrator type tools, but this du command here, that's a disk usage utility. So you might use the man page on it to see what the du command actually gives you, but this is just an example of how you might use various Linux utilities as a system administrator in a system. So the basic idea here, though, is this gives you a report on a particular user's use of hard drive space. How much storage space are they consuming? Then we have one that does a little bit of math. This BC in red here, that is a calculator utility, so it looks kind of weird, but I'll show you an experiment of that before I close down today so that you can see how and why we use the BC calculator utility. But basically it gives us the ability to do fancy math in our scripts. There's another select statement, my favorite thing. Here's a while loop that actually processes a file. And then the for loop, just to kind of toy around with an idea for using a script. So in this case, it'll give you a bunch of information about a file just formatted. And then finally, and again, this is largely for the system administrators, but I thought you might be interested to see this. This last script example shows you some different ways to use the date utility and format its output. So you can actually change what date spits out and format it in different ways. So I just thought I'd show you that, and then you could in this script see the different formats and what they do. And then just some ideas again about things that you might do in a shell script. Who am I, you know, but information about the host name of the machine you're on, the IP address, account of the total number of users who are logged in right now, just some stuff to expose you to some different ideas that you might employ in a shell script. And again, you can kind of get everything that you need even as a system administrator on the command line. You don't really ever need a graphical user interface, although they are highly convenient. Okay, so anyway, that's the example. So you'll see some of those come back here as I go onto my machine and play around a little bit. Okay, so let's make a script. I'll just make a hello script in here and do a few things in it. Don't forget the shebang. Now here just a reminder, the shebang is there so that you guarantee that this script actually executes in the shell environment that you want. We want the bash shell. So the easiest way to get this information once you're already in VI is escape in command mode. colon, and then a bang, and then you can run a command. I want to say which bash, and the only reason I'm doing this is because I don't want to exit VI to run the which bash command. I can just, right inside of VI, I can run this command. I can see its output, user bin bash, and now I'm still in VI, and I will just complete my shebang line. So that's all. That colon bang command runs the command inside of the VI editor, shows you the output, and then you can incorporate it into your script. So there's the shebang line. So I just want to show you. Let's do one with. Let's just do a couple of dash n's. So the dash n on an echo statement means don't put a new line. So what should happen when this shell executes is it's going to type hello and then no new line. So the next echo statement, the world, is going to be mushed right on the end of hello because there was no new line. And because world has no new line, watch what happens when the script runs to completion. So just a couple of echo statements, but both with the dash n option so you can see how that works. So if I run ls, I'll notice that my hello is not executable. Remember, you have to make it executable. I'm just going to make it executable for myself, not other users on the system. So here's the hello world. So notice two things. One is that hello with no new line, echo dash n, means that the next echo is mushed right on the end of that. And the world with dash n, no new line, means that when the script is done, the shell itself actually just tacks its prompt onto the end of that without any new lines. So the fact that hello mushed with world, mushed with the prompt after the script is run, that's all because of those dash n options. So if we take the second dash n off, and then let's say we want to put a space in there. So this will be hello without a new line, and then space world on the end of that. And then because the second one doesn't have a dash n, it will put a new line. So there's the hello, and then no new line, space world, and then a new line is why the prompt comes out on the next line down. So that's what the dash n does. And the reason I'm showing it to you is because I like to use it for things like this. I like to put a space here at the end. So I'm going to ask the user for some input here, and I'm going to put the dash n on it. I know I've talked about this before, but when I teach programming, I find that people actually really struggle with this. So just making sure. No new line. So what is your name? Space. So when this echoes on the screen, the cursor waiting for them to type stuff is going to be sitting right next to the question, and when they type their answer, it'll be on the same line. Now, as soon as they hit enter, the terminal is going to put a new line in. And then we're going to use read. And what the read command does is it reads keyboard input. So it will store whatever they type as name. And then I will say echo, nice to meet you, name. And then I'll recall the value of the thing that I read with the $sign. Right? We've done this before. So the reason why I like the dash n is because I can use it to do things like make prompts for people. Just like the command line, right? You can imagine the command line is printing out the prompt part of your command line, and then no new line, so that what you type at the prompt is on the same line as the prompt itself. That's all that means. I'm actually going to go and delete these two. Okay, so here's an example of read. So I'm going to echo without a new line, and you'll see that I type my answer on the same line. Press enter, and then everything that I type is going to be stored in this variable, and then it's going to say nice to meet you, and then it's going to retrieve the value of what I typed. So see, there's the no new line, so my answer. So it's going to read that as name, N-A-M-E, and then $name retrieves the value that it read from the keyboard and adds it to that output. So there's a read. All right, so I'm going to comment these out, and actually not that one. So we're going to replace that whole sequence with an alternative. So we can do this sequence of prompting and reading all in one fell swoop with the P option to read. So if you read with the -P option, you're saying I'm going to read and I want to include the prompt in this command. So what is your name, space. So read, print a prompt, that's what the -P means, and then store here. So you can actually achieve what I did on lines 3 and 4 all in one line like we did on line 5. For some reason I forget to do this and I use the echo-n style a lot, but anyway, I can read and the command will actually allow me to include the prompt that I want to show alongside it. So that's what the -P option does. I'll go run it and you'll see that it's exactly the same as what it did before. So there's read-P printing the prompt. When I type my name and hit enter, it's going to store what I type in name, and then it's going to recall what it stored that I typed from name, $name, and print that out. So that's the -P option. And then the last one, and I know we've done these, but I thought it wouldn't hurt to repeat them. So there's also a -S option. So I'll use an echo-n, I'll do a read-s secret. So -S means read silently, and all that means is that as they type their answer, the characters they're typing won't appear on the screen. So it's a way to hide, read silently. So you can hide what they type, but you still get what they type in secret. So you can say, so we can still recall that data, just as they type it on the screen it won't show. So in theory this is a way to slightly enhance the security of a script. And I know we've talked about this, but just there's questions that go through these things again I think this week, so just thought I'd repeat it. So here's the first one, the read-P. There's the prompt. I'm going to type my name. So here's the echo-n this time, saying what is the secret word. And now when I type, it's reading it silently. So the characters that I type don't echo on the screen, but when I press enter, it will store what I typed and then print it out. So you notice there's something a little bit weird here, is that after the silent read, there was no, when I pressed enter, there was no new line. So what I typed, applesauce, is there in fact, but there was no new line in between them, so that's something to remember. All right, one last one along those lines. So let's do this instead. Let's comment these out. So we can do all this in one fell swoop. So we can do read silently and print the prompt. So we'll just do it all in one fell swoop. We'll do a silent read, we'll print a prompt, and we'll store what they typed in secret and then print that back out. And we'll see if there's any difference from the last time we did it. So just kind of combining up all the options into one thing. I misspelled it, I think. Okay, so it still worked, although notice it's still, there's no blank line before that. So the silent read appears to dispense with that new line, so you have to actually, if you're going to do a silent read, probably right after that you should put a blank line out. So I'll do a silent read, I'll put a blank line out, and then I'll print the output. I'll show you that real quick. So the echo empty quotes, that's just print an empty line. So there's the empty line actually caused the line break this time, and then there's the secret word that I typed in. I didn't misspell it this time. Okay, so that's all the that's the read and the echo stuff. Those are your basic ways for interacting with someone on the screen, or at least producing output, right? So if you need to see what your script is doing, echo statements. If you need the ability to get some keyboard input, ask and answer questions, then read command. So there's that. So let's do a, let's go back into hello. No, I'm going to do a different one, I think. That one's going to get to be messy. So I'm going to sit on this for just a sec and make sure people have a chance to read it. So I've commented out lines 3 and 4 and lines 9 and 10 and replaced them with the read with the prompt. And on line 12, I'm spitting out basically a new line because I notice when I do silent reads, there's no new line on the screen and it looks messy. So I actually have to manually put the line break in with an echo statement. So that's my hello script. Okay, so let me see if I accidentally have one called loops already. Yeah, I don't. All right, so let's make I'm going to make a new one called loops, and look at some loops. So do my shebang line. Okay, so let's start with the for loop, and we'll do a really sort of simple one first. So we'll just say for number in 1, 2, 3, 4, 5. You can put the do here, by the way, or you can put the do on the next line down. Either way, I think in this case, okay, so let's just talk really quickly about what for loops are designed to do. So what they're designed to do is take a set of inputs. In this case, the inputs follow the keyword in. So the inputs are 1, 2, 3, 4, and 5. So the for loop will cycle through each of these inputs one at a time, storing the individual input as number on each repetition. So the first time this executes, it will take the 1 as number. The second time, it will take the 2 as number, and then the 3 as number, and then the 4 as number, and then the 5 as number, and then stop. So let's echo. So the idea though is that we are working through a set of data one piece at a time. So the set here is 1, 2, 3, 4, 5. Each repetition, we grab one number and assign that to this variable number. So here we're going to say number is, and it'll say number is 1, number is 2, number is 3, number is 4, number is 5. At least that's what I want it to do. So that's the idea. You take a set of inputs, you assign one input at a time to some variable, and then you can do operations inside between do and done. So for now, we're just going to take each number and say the number is, just to show that it should say number is 1, number is 2, number is 3, number is 4, number is 5. That's how that one should work. Hopefully. I keep doing clear because I want you to, so I need to make that executable, of course, because it's new. So there it's cycling through the set of inputs, 1, 2, 3, 4, 5, as expected, of course. I'll do another one, so we could say sort of like, so for fruit in apple, orange, banana, strawberry, do. So here again, our list of inputs is apple, orange, banana, and strawberry. It's going to take one of those at a time, assign it to fruit, and then inside my do done loop, I can say, for example, I like and print those out one at a time. Now this isn't super useful, I just wanted to show you the basic functionality of the for loop. And I'll show you sort of something else that's a little bit more interesting. But you give it a set of inputs, a list of inputs, and you cycle through that list of inputs one at a time and do something with them. Same deal, right? So now let's just show you a couple more variations that make this thing quite powerful. So you can also you can use the shell's wildcard capability, and it can be confusing unless you're sort of writing this knowing what you mean to be doing. But you have to imagine that this is the same wildcard as you use on the command line for like a file listing. So Bash will interpret this star as all of the regular files in the current directory. Put a little arrow because that's what I want. So you can make a list of inputs not just by manually typing in a list, but you can actually pull the list from file listings or from the contents of files that we'll do an example of and see how that works. But anyway, here's a star in this case, and let's just see what that does. I'm going to go add blank lines before each section so they're separated out. So I added lines 8 and 14 here just to put a blank line between the sections. So I'm going to use a loop to work through the entire list of all regular files in the current directory. And at least that's what I think that I'm doing. So here's the files. So then you'll notice that when I used the star, what the shell interpreted that to mean was all of the regular files in the current directory, and then it's printing them all out. So that's a pretty cool thing. I should have called this for loops. You can also, instead of a star, you can I lost my, oh yeah, I need to be in insert. We can use the backticks, and we can actually, so those are backticks, but what I've done here is I'm going to actually use the ls utility to only list the files that have .txt on the end of them. So I can actually loop through all of the txt files if I want to, or maybe I'd rather use the, do the shell scripts instead. So I can actually use the for loop to cycle through a specific set of the files. These are backticks. That's the, over the tilde key, that character, the backticks. So that will create a list for me that I can then loop through of all the files that end in .sh in the current directory. Pretty nifty thing. So now it's only processing the .sh files, which is pretty neat. Okay, so one more for loop example. Well, let's see. Do I have a file of anything? Okay, those are empty. Oh, I can do a long listing. Yeah, they're all empty. So one thing I want you to see is that I created these file 1, 2, 3, 4, 5. That is for an upcoming experiment, but they're all empty files, so I just used touch, and then I made one of them executable just so that I could do some shell scripting experiments. Because remember, we have the ability to test files and see if they're executable or not. Okay, so I'm going to do one more for loop example, and then we'll do some while loop examples. Okay, so here's one last example, empty line using for loops. So for I'm just going to call it n this time. Okay, another thing you can do though is you can use this $@ symbol. What that represents is the grouping of all of the command line arguments. So you can actually use a loop to process all of the command line arguments. And then we can do something like this. So for each of the command line arguments, we're going to grab that and call it n. And I'll show you a usage here in just a second, but let's just do a let's do a command on it. Let's do a long listing of, so here's the idea. They're going to give us a set of numbers on the command line. We're actually going to take each one of those numbers separately in sequence as n, and we're going to insert it as a file name. So this would be like file 1, file 2, file 3. I'll show you an application here in just a second. We'll do a long listing on the files by number that they specify on the command line. So that's the $@, which is the list of all of the command line arguments. So the idea here is that we run loops, and then we're going to give it, well, let me go back one. So I want to see file 1, file 2, see the file with an n next to it, file 1, 2, 3, 4, 5. So if I were to run this with 1, 2, 3, 4, 5, it's going to take that list and call each of them n, and then say file 1.txt, file 2.txt, file 3.txt, file 4.txt, file 5.txt, and then see the last section where it does a long listing on them. Now if I want to, I can say, well, I only want to see files 1, 3, and 5. So notice it only gives me files 1, 3, and 5. Now if I do like file 10, I get an error because that's a non-existent file. So let's go fix our script as our one last step to address that problem. Okay, so when they give us a list of n's, they may put an n in here that's a non-valid n. So what we want to do is use an if statement to make sure that a file of that name exists. So before we try to do a long listing on a file with those n's, we'll just check to make sure that it actually exists before we do that. So there's just a little improvement on this last part of the script. We'll take each of those numbers, we hope they're numbers, we'll check to make sure that it exists before we actually try to do a long listing on it. So let's see if that improves our script. I'll pause for a sec. Okay, let's see if that fixed it. So that if we run it with this last one, or you give it a file number 10, it shouldn't give us an error anymore because that's just a non-existent file. So you see this time around, it doesn't produce an error because it checked to make sure that there was a file that looked like, and now I can put whatever I want on there. And it will try to put file apple.txt, file oranges.txt, but before it actually operates on that file, it checks to make sure it exists. And because it doesn't, no error happens. So that's a slight improvement on that loop. Okay, so there's a few for loops. I think we're doing okay on time. Yeah, so now let's do some while loops. I am going to move my loops file to be forloops.sh. And that way I can create a while loops.sh, which is going to be a pain for me to type. At least I'll remember what I was doing in there. Okay, so the idea of a for loop is that you can take a list of information and you can operate on one piece of that list of information at a time. So while loops are a little bit different because they're designed to operate as long as some condition exists. These aren't the only loops, these are just sort of the ones that are highlighted in our reading. So let's shebang this. Okay. So we'll start with, again, sort of a very basic while loop. And let's do it with a counter this time. So let's just start a count at 0. And then we'll say while the count is less than, remember that's a number. Not a bad idea, by the way, to just quote these things. But since it's a number, then the way we do comparisons, so let's say it's while it's less than 10. So this loop is going to be a counting loop. And of course we need to be careful that the count actually changes over time or we'll get stuck. So this is a loop that's designed to do something 10 times. We'll start count at 0, and as long as it's less than 10, I guess maybe you're probably going to prefer, let's count from 1 all the way up to 10. So we'll start at 1, and as long as we're less than or equal to 10, which means that we'll stop once we hit 11, then let's just say, okay, got to get back in insert mode. Let's just output the count. And then we have to do a little bit of math. So the trick here, it looks funny. So we need to, there's two ways to do this. I'm trying to make myself learn how to do the nicer way. We need to make sure that every time that we do this repetition that we bump up the count, and I believe you say count equals count plus 1. So we'll bump up the count by 1 each time. So what we want it to do is say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will finally hit 11 and then it will stop. That's what we would like to have happen. Doing math inside of shell scripts is a little bit painful, in my opinion. And if you have done some programming, you should also know that you cannot do decimal arithmetic in a shell script. You can only do whole number math in shell script, at least by itself. It doesn't know anything other than whole numbers. Okay, so there's a counter. Should do it. Count equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then stop, we hope. That's my while loops. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just to show you a while loop. Now we might no, that's enough for that. So there's a counting loop, so you can do things a certain number of times. We could, well, let me go back in there and leave that one alone. So echo, so that the second section is. So anyway, that's one way that you can use the while loop, is if you know you need to perform some task a certain number of times. I mean, I'll give you an example real quick, which is, I know I have file 1.txt, file 2, file 3, file 4, file 5. So I could reset my count to 0 here, and then I could say while count is less than or equal to 5, because I have 5 of those things, do ls-l file count. Oops, this should be 1. I'll count.txt, and then count equals So one thing I'm bad about, just so you know, is the spacing of stuff, but Bash is pretty sensitive about the spacings of stuff, so Bash does not want you to put spaces around the equal sign. I'm not sure if the spaces around the plus are required or not, so you could try it, although I find that easier to read and it's working, so I'm going to leave it alone. The other spacing thing to be mindful of is the square brackets here. Where we actually do the test to see if the count is the right value, that space has to be there around those. See on the insides of those square brackets, that space has to be there. Okay, so anyway, I'm just going through my long listing of files. This time I'm using a counter, so starting at 1 and going all the way up to and including 5, and doing long listings of all the files that I created in this directory. So, same idea as before. But then I want to show you one other thing that I think is cool about this. It's the same as you're going to see in the lab assignment, but it's also kind of one of the fun places to do an experiment on. Actually, I bet we can. Let's do 2 more. How am I doing on time? I think I'm doing okay. Let's do 2 more. So we should. So one. Do I want to do it? Let's try it out and see what happens, shall we? So there's also a thing. Let me put a blank line in here. So, oh yeah, I have to do a select, so I need to leave time for that. So another way that you'll see people use the while loop in a bash script is to actually read through a file as inputs and process them. So I'm just going to start, and then I'll build up a little tiny script around it. I'm just going to start, but the setup is entry do done. That looks wrong to me, so I feel uneasy about that, but well, we'll get an error and we'll fix it. Okay, so the idea here though is, and it looks kind of funny, but when you see a while read loop, what it's really meaning to do is accept some inputs. I'm going to use the password file here. This doesn't look right, so I'm going to have to probably deal with an error here in just a second. So this is kind of weird, but what will happen, I think, do I have to do cat? I don't think so. I think the way the shell will process this is it will read the etc. password file. That's all the user information, one line at a time. So the read will actually read one line from this file down here and call it entry. And what we'll do for starters is we'll just echo the entry out. Something feels funny about that, so we're probably about to get an error and we're going to have to fix it. So this looks kind of funny, but you're actually feeding the while loop a file as its input down here. So I'm feeding it the password file, and then I'm reading one entry at a time from the password file that I'm feeding in. The setup is just super strange looking, but what this should echo is each of the individual entries in the password file. Although the way it's highlighting makes me think that I have a mistake. No, it worked. Okay, so this output here is all of the lines of the password file brought in. So I fed a file into my while loop, sort of from the bottom, and then I read each line and call it entry, and then I do something with each entry. Let me go back. Let's go see. Let's use cut to process those entries and get some information perhaps about our users. So let's cat the password file. Okay, so let's just pull the home directories just for fun. So let's see, the home directories is the 1, 2, 3, 4, 5, 6th field is the home directory. So I'm going to use cut to target that. Okay, so instead of echoing the actual entry, what I'm going to do is I'm going to say home dir equals, and then I'm going to use backticks to capture the result of a command. So I'm going to cut the field separator in the password file. So I have to sort of understand what each individual entry looks like. It's one line of text from that password file that has a whole bunch of stuff separated by colons. I'm going to grab I can't remember which field it was. Was it the 7th field? No. 2, 6th, something like that. No, let's I feel like I need to echo the entry through that. So I'm going to use echo to push that entry through my cut command. So I'm going to echo that whole line and then filter it with cut, and then capture that whole filtering process as home dir. So that one got to be a little bit, we'll see if it even works. We'll see if it works. So, but anyway, what I'm going to do is use the echo statement to push that whole line of entry through a cut filter. And grab the 6th field, which I forgot which field it was. That might be the wrong field. Store that field for each individual entry is home-dir, print it out, and then the while loop will automatically move to the next line, push that entry through my filter, and then print out that field that I filtered. Hopefully. That's what it does. Yeah, so lucky guess. Am I in here? There's my home user. Some of them, by the way, don't seem to have an actual home directory, so it just comes across as the root directory. But those are all the home directories that I have filtered out of the password file, which isn't actually where the passwords are stored, but it does have basic information about all your users. We've played around with that file before. So I've tried to just sort of give you a walkthrough the thought process, but you'll find in the lab assignment this week that I've done similar things to try to expose you to so just some basic ideas, a couple of new utilities, but also just the basic usage of some of these looping setups in Bash shell script. So there's the while loop ones. I need to do a select. Yeah, I need to do a select. But I do want to show you one sort of one-off thing before I do selects. Or should I do selects and then do the math? I'll do selects and then I'll do the math. How are we doing on time? I'm just about out of time. So let me make a new script called selects. So do a shebang for it. Okay, a select statement is a little bit like a for loop in that you give it a list of things. I think it's a do done setup. But I want you to see the difference here. And probably we can run this. Let's just put nothing in here for now. So this is not quite like a for loop, but it does kind of have a similar setup. So you give it a list of things, and then you'll see in a second when I improve this what actually happens. But you give a select a list of things, and let's see what it does with that list. I'm assuming this works. So this is one of my favorite things in Bash shell scripting. So the select statement actually takes the list that you gave it and it makes a menu out of it, and then it actually puts a prompt here and you can make a choice off the menu. Pretty neat. And it's kind of like a loop because you're always in here. So Control C to kill this, by the way. So it makes a menu out of these, which is super, super cool. It gives you two pieces of information. So we'll watch what it does. The fruit is from my select here, but basically the select statement will automatically, based on the user's selection out of the menu, assign the proper value to this variable. And this reply part is automatic, so every select statement knows what your most recent reply by number is. So that's the number that you select, and that is the automatically assigned piece of information from the set of available options. So I'll select Apple. Oops, my numpad is not. Numlock. So I typed in a 1. It automatically attached the first value to my fruit variable, and it remembered as its reply variable that was option number 1, 2, 3, 4, and so on. Any other number, by the way, just comes back as nothing. So, pretty neat. How that works. Where am I? Okay, so what you'll often see though is you'll see these combine with the case statements. So you'll often see these combine with case statements so that you can respond. So you can say, for example, in case they typed apple, I also like apples. And then the, for now, anything else. Actually, we can probably say, well, let's not worry about that. Let's do a break here. So I think the break will actually break us out of the select statement out here. So it's kind of like a for loop, but it's really for generating a menu and giving you, then you can select from the menu and do operations. I like apples also, as an example. You can also, by the way, like, you could add like a stop option. Let's call it quit. So you could actually actually make it one of the menu options that they say, I want to quit now. So anyway, you give it a list and it kind of spins up this menu for you, and then you can use the menu, like for example, in combination with the case statement, to respond to the different options that you've created. It's super, super neat. So there's my options. I like apples also. I didn't do orange yet, banana, only if they're mushy, and then if I do 5, it exits out of the select statement and the script is over. So love the select statement. I think it's just the coolest thing. And I'm not going to, kind of out of time, but let me just show you that just like a for loop, you can say select file in so all of the files, I can make my list for the menu of the files that say file something.txt. I could immediately break after one selection if I want to, by the way. So anyway, you can also, for the select, just like you could in a for loop, you can spin up the list that it makes the menu off of with like a file listing or the contents of a file with a cat statement. There's a whole bunch of ways that you can be kind of clever about this. So I'll quit that one. So there's the looping through the files. And this time, it breaks after my first selection. So love the select statement. Okay, so I did it to myself again, which I apologize for. I hope, and you can let me know if it's causing you trouble or you're not being successful with it or I've got a flaw, but if you are interested in doing the desktop stuff, hopefully my instructions are good enough. I'll show you kind of one of my end results real quick before I close out. But I wanted to show you also, you cannot do decimal math in the shell. So if you needed to do something like how many, if a donut is 75 cents and I want to buy 10 of them, what does that cost? So in the shell, you can't actually do that. You can't say let cost equal 10 times 75 cents a piece. It just won't do the math. Because in this case, I just didn't do it right, but because it took the star and did a listing of it. But it won't do that math correctly. So instead what we used is, from the command line at least, the BC calculator. So if you type BC and hit enter, you're actually in the calculator and you can do math like that. And you can just sort of type math in the BC calculator. I'm going to do Control C, to get out of there. So the BC calculator, but if you need to do it from a script, then what you would do instead is you would use an echo statement and say 10 times 0.75, and then, hold on, let's single quote, I think, 10, well, let's just, I feel like, I'm going to try it, but I think it's not going to work. You can pipe that into BC. So I need to, actually, I don't even know why I am doing all that. So I just wanted to show you real quick that you can do fancy math from the command line by echoing the math that you want to do and then piping that through BC. Math is a real pain to do in shell scripting, so you can use the BC pipes, which I've shown you an example of in the lab this week, but that's why that's there. You can also do things like, you can change the number of decimal places. So I actually didn't do what I wanted. Why didn't it do what I want? It didn't do what I want. I'm not going to worry about it. I probably have a better setup in the lab assignment. Anyway, that's why that's there, is because you can do fancy math with BC. So if you take your fancy math and you use echo and then pipe it through BC, it'll actually perform the math for you. So that's why you're going to see that in the lab assignment. Okay, let me show you what I got for the desktop managers and desktop environments, and then I will shut up. So let me shut this machine down. And then I know that I'm going to have to fix the view for you. So I'll fix it here in just a second. When I get my clone 2 that you see there, that has my desktop manager and desktop environment in it. So let me boot it up and show you real quick before I shut up for the day. And I'm pretty sure I'm going to have to, okay, let me fix this. Okay. It's all kind of fit in there, okay. it's all the graphics. It just takes long. Okay, so what you're seeing here is called a desktop manager. You saw this at the beginning of the semester with Lubuntu, and many of you saw it on your team project 1. A desktop manager looks like a login screen, but it's more than that. So a desktop manager is not only a graphical login screen, but it's also a way to tell the system what environment to bring you up into. So desktop managers will somewhere always have this selection for you. So I can go into OpenBox, I can go into an XFace. My budgie is not working, I get a black screen. Cinnamon works, but it's a real memory hog, so it's super slow. So this is the desktop manager part, which is a login screen, and also the ability to select the session that you want, which is super awesome, because if you install a whole bunch of different graphical environments, you then have the ability to log into different ones of them. So now I selected XFace, and then when I log in, I'll go into XFace. So that's kind of the result that you're looking for, is to get a graphical login screen, which is called a desktop manager, and the ability to select between different graphical environments. XFace works great for me, which is mouse's trap why I'm using it here. Then I'm just going to go ask myself real quick. Didn't we do a different display? Oh, we did light DM. Let's try it real quick. So you can also go change your display, the login manager. So I'm going to try it. Sudo system control enable or disable. I think, am I in GDM? Maybe. And then I will enable light DM, hopefully. I don't have a light DM. Do I have SD DM? I do. So you can switch the display managers once you're in as well. Now the downside to this is that you have to reboot really to see it. I believe. I'll log out and see. But I think that I'm going to have to, I want to log out. I think I'm going to have to reboot to change display managers. Yeah. So let me reboot. Does this mean reboot? And then we'll see a different display manager, which is a graphical login that allows you to select the desired session. You probably just lost the view of things. Okay, no, it's still okay. All right, last thing. Thank you for your patience if you're able to stick around. Anyway, this is the bonus content. This is the results of doing the desktop manager and desktop environments. So the desktop manager, again, is just the login screen, but it allows you to select your desired graphical desktop. And then the desktop environment itself, of course, is the graphical environment once you're logged in. So let's see if I get, I guess that's SDDM and not GDM. So I don't know what I did wrong. Anyway, I'm stopping there. I've run up against your time. If you follow those instructions, you will get a different graphical environment. And just a heads up, sometimes before you get the list of choices, you actually have to sort of select the user you're going to log in, and then you'll see like a little gears icon. And then if you can find the gears icon, that will be where you can select what you want to log in to, which I failed to switch to a different. I guess I took light DM off or something. Anyway, I got to stop. I've run well into your time already for the day, so thanks for your patience. Hopefully you have a great week. Let me know by Piazza or Canvas inbox if you encounter any issues. I apologize that I didn't do the full walkthrough of these graphical environments, but probably don't want to sit here for another sort of 2 hour session. So I hope that I put the instructions together enough that you can actually make something work. But again, if it doesn't, please let me know and I will address it. Okay, so one more week of content, one last week of sort of the features of Bash scripting. Thanks, Justin. Appreciate it. Have a great week, everybody, and I'll see you on Tuesday next week. So take care.